In this question, we want to compute a derivative of this function, which is given with a variable limit. So we have to use the fundamental theorem of calculus to find the answer. One thing you can notice over here is that the lower limit is variable and the upper limit is variable as well. So first we need to understand what is fundamental theorem of calculus. Fundamental theorem of calculus says that if we have a function that is continuous on AB and if there is a limit, variable limit, upper limit is variable and the lower limit is constant. Lower limit is constant and upper limit is variable. Then what happens is when you solve this definite integral, you get a function which depends on x. So theorem says that when you take a derivative of that, for example, if you take a derivative of this function with respect to x, then after taking derivative of that, you get only f of x. This is the statement of fundamental theorem of calculus. One thing we should notice that the lower limit is fixed in that case, and if you look at the question, the lower limit as well as upper limit are variable. So we cannot directly apply fundamental theorem of calculus and compute df by dx. So what we do, first we need to have constant limit in the upper limit. So we can write this f of x as 2x to 0 t square plus 1 under root dt plus and 0 to x square t square plus 1 under root dt. So what we did, we use a property of definite integral which says that if we have a to b f of x d of x and if there is an intermediate point c in the domain, you can write your definite integral as a to c f of x dx plus c to b f of x d of x. So we use this property on this integral. Now the next thing we want to use is change the limit. Here the second integral has lower limit which is constant and the upper limit is variable, but in first integral the lower limit is variable and the upper limit is constant, and fundamental theorem of calculus says that the lower limit should be constant. So we use another property of definite integral and change the limit from 0 to 2x and write negative sign t square plus 1 under root dt plus this remains the same t square plus 1 under root dt. Now we brought the form, we bring the form which is where we can apply fundamental theorem of calculus. So I take a derivative on the left hand side, which is the question of which is the question df by dx is equal to minus, we take a derivative of right hand side 0 to 2x, 0 to 2x, t square plus 1 under root dt plus 0 to x square, I'm sorry, there should be d by dt, I'm sorry, d by dx, t square plus 1 under root dt. So according to fundamental theorem of calculus, that says that you have to replace this t with 2x. So we can write minus 2x whole square plus 1 under root. As you can see, according to this theorem, we just have to replace this t with x, this x. So we replace this function with upper limit 2x plus, then for another definite integral, we have x square plus 1 under root. Okay, one thing we are missing over here is the chain rule. So we have to use the chain rule as well, d by dx to x. Since here in fundamental theorem of calculus we have x over here, so when you take a derivative of this equation, then there is no need of applying the chain rule. But here when you have other than x, which is multiple of 2 or some other function, then you have to apply the chain rule as well. So we get d by dx and the derivative of upper limit. Then we get minus 4x whole square plus 1 under root 2, the derivative of 2x is 2 plus x raised to power 4 plus 1 under root, then we have 2x. So this is df by dx. That is the answer of this question. That is the answer of this question. Thank you for watching.